as this cell multiplies into many cells, they begin to specialize into bone cells, gut cells, heart cells, udder cells, and eye cells.
You forgot skin cells.
Shut up.
Together, in combination, they make a sheep.
But here's the sad part.
If we were to remove one of his eye cells,
He's going for it.
ow!
We would see that since this cell is now specialized, if we would say, hey, can you do this, huh? It just sits there. He's not doing anything. It can only be an eye. Loser! It has forgotten how to build a sheep.
Now, this is cell differentiation, what they're describing?
Yes, yes, it is. That's correct.
So is that why I couldn't pluck a cell from your eye, say, and say to it, now go ahead and build me a whole new Lee Silver, because it has forgotten how?
Well, actually, all the genetic information is there, we now know, but much of it is covered up. And
What is what?
Is covered up.
Covered up like this?
For example, remember the eye cell we plucked from our sheep?
Look, right there.
You want to see why it's an eye cell? Yeah. Go for it. Well, its DNA is right here. I've seen this before. With this addition. I haven't seen that, doll. Notice all the instructions are covered up with X's except this section right here? Uh-oh. Well, this section tells the cell how to make an eye. So if we look this cell in the eye and we say, go ahead, build us a sheep. I can't. I've forgotten it.
Oh, dear. But I can help this cell remember how to create an entirely new creature. This was Dr. Wilmot's great accomplishment. Suppose that this is the DNA from an eye cell, and as you see here, every information right here, this is called how to build an eye. Cell can't remember how to do anything but this. What Dr. Wilmot figured out was how, very carefully, to remove all these covers, all these blockers, just so.
So now that cell's genetic material is completely open, and now it can be reprogrammed step by step to go into any tissue in the body.
And build a whole sheep.
And build a whole sheep.
And that is how we got Dolly. And more recently, that's how we got those mice, the cloned mice from the University of Hawaii. And then this cow, also cloned. And using the same technique, I wondered, can you now clone a human being?
It's almost certainly going to be the case that you can clone a human being.
Using that technique?
Yes, and we know that because it has worked in every other mammal in which it's been tried to date.
And it may have already worked in humans because, and this is the guy, Dr. Jose Sibeli, a research scientist, revealed that at a lab in Massachusetts, he had successfully begun cloning himself. He has not published his data or agreed to an interview, but in this video press release, he said,
"We have developed a method where we can take a cell from an adult, let's say a cell from under skin."
Which is just what he did. He says he took adult cells from the inside of his cheek, and then using roughly Dr. Wilmot's recipe, he removed those blocks or covers so the cell could now remember how to create a whole new creature.
And we can transform that cell into a stem cell. A stem cell is a cell that can develop into any type of cell in the body.
And then he got that cell to divide, which is the first step to creating, well, a clone, Dr. Sibeli's twin.
In a sense, it was an embryonic twin of the scientist. That's correct.
But then, after several divisions, Dr. Sibeli says the cells stopped growing. But still, each step toward cloning, toward designing a baby to be a copy of someone else, steals from the baby its greatest mystery. For millennia, whenever you had a baby, you didn't know what you were getting. Well, says Lee,
you really still don't know what you're going to get, and you never will know really what you're going to get.
But I think people do worry about tampering with the mystery of childbirth, because the mystery, actually, I can show you a dance which captures this beautifully. The mystery is that since you don't know what you're getting, you're prepared to fall in love with anything you get. Let me show you this. Jody Oberfelder has designed this dance for very new mothers and their very young babies. It is set to the lyric, "Who are you and who will you be? And who am I now that we are we?" look at babies this age, you're looking so closely for signs, thinking, now, is that her mommy's smile? I think so. Or look at that, she is going to be musical, just like her dad. This is the age when you look for clues, for signs of what they're going to be one day. But what if the baby's a clone? What if they're designed to be like, to look like somebody else? If these babies were clones, would we watch them? Would we love them the same way?
I'll say I rock you, baby. I want you, mama. I want you, baby.
Could it be that cloning might disturb all this love we've got going here and this innocence? But what exactly should we fear? Well, we will get back to babies and to that question when we return.